Hi there. In this training video, we are going to do a quick introduction of Q, and we will also cover the various aspects of designing a control system. Q as a company, we are founded in 1991, which is approximately 22 years ago from the time this video is recorded. Our head office is located in Prague, which is the capital city of Czech Republic. Production facilities is located 100 kilometers north of Prague. Due to cost reasons, shifting the production facilities away from the city will actually reduce production overheads and costs. Our company's objective has always been and will always be development, production, and sales of complete automation systems for various types of applications. Applications can be from small size, comprising of one meeting room or a home theater, to multiple meeting rooms, multiple theater, medium-sized installation, to even large-scale installations for the whole building or the whole home. Comprises of many interconnected systems. The limit for expansions is limited by IP, as our system is using IP as the primary communication backbone. Our target markets has always been commercial and residential, which is primarily for offices and home automation. One of the key features that for Q is that the look and feel of our Qnium 2 series comes with solid aluminum enclosure. Our new CVC software allows for quick and easy development of the control systems using our product range. This software was a software replacing our previous software by the name of XPL System Director and was launched 5 years ago. This software has been designed with the design philosophy of supporting controls and automation systems for the next 10 years or more, and comprising of new technologies like video streaming, audio encoding, Next, now we talk about design of control system. Why do we need control systems? Mainly because we have too many remote controls and buttons and not enough hands. Alright, as shown in this illustration, you need a remote control for air cons, you need a remote control for security, you need another one for lighting, another one for audio equipment, another one for video. So you have a basically you have a controller for each and every equipment. So if you want to do something like, for example, you want to use the room for AV, you have to press a remote on the audio system to power on the audio, a remote to the video to actually power on the video, the remote to the lighting to actually switch off the lighting, and the remote to aircon to actually set the room temperature for a meeting or a movie viewing. So in order to do that, you have to use the 5 remote controls to gather just one function for the room. So it's actually pretty complicated. So that's where control systems will come in, whereby the better solution will be to integrate all these other systems, all these 5 systems, into one single solution. From one touch on the touch panel, I can do all the functions that I've mentioned just now with one touch. How does the system work? Firstly, we have interfaces. Alright, the user, the client, or the end user can use and control the system using the interfaces like touch panel, like the AirQ touch panel here, a PDA, or in short, mobile device like your phone, a wired touch panel, keypads, and wireless button panels. So all these interfaces are available to the user to actually interface with the system, to send a command to power up the system, to switch on the lights, to switch on the aircon. And we have a controller here that is connected to the various interfaces via LAN or via our proprietary bus called the Q-wire. And in turn, the controller will have the necessary connection to all the AV equipment. For example, a Blu-ray player controlled by infrared, we will have an infrared port and an infrared adapter to connect to the Blu-ray player and sending Blu-ray player infrared commands to drive the Blu-ray player for the certain functions we need. And similarly to lights, we have the various lighting interface for dimming and various electronic lighting support like DALI, DMX. We have various interfaces for various types of lighting systems. So this contributes to an automation system. And this is how an automation system works. In short, when the user presses a button on the panel, a command will be sent to the switch and in turn sent to the controller, and the controller defines the functionality of the command and sends an infrared command or a command to the lighting modules to switch the lights on and off accordingly. So this is how a control system works. In terms of system communications, Q actually relies on internet connection, which is both wired and wireless, and power over Ethernet is available for all new products, namely the Qnium 2 series products. And this interface is used by all our controllers, touch panels, as well as our new port extender interface. The product name is Smart Qs. Q-wire, which is actually based on a serial standard by the name of RS485. The Q equipment that runs on Q-wire are the keypads, inputs, and sensors. P-bus, another proprietary bus that we have, also running on RS485, and this interface is for power and lighting interfaces. And note, however, P-bus and Q-wire, although they are both buses and both from Q, but they are non-compatible with each other. So if you want to use the particular serial port for 485 for Q-wire, you will not be able to use the same port for PE bus, although 485 is actually a bus standard. This is due to the difference in protocol between the Q-wire and PE bus. As I have mentioned just now in the design, we have different devices, and how the controller controls the device is actually through the interface or the control interface that's available on the device itself. So on the controllers, we have got different interfaces that's available on the controller to control the various devices out there in the market now. As in the market, there is no one fixed standard for controls, so we have different control ports to fill the gaps for different devices out there in the market. So the ports that we have namely are serial ports, infrared, which is IR port, general I/O, digital I/O, relay or aux port, analog 0 to 10 volt, and the LAN port. And we are going to run through each of them in the following slides coming up. The number of serial interfaces available in the market right now are 3 types, namely RS232, RS485, and RS422. What are the difference for each type? One big difference is the cable distance. RS232, the cable from the controller to the device being controlled must be less than 10 meters. It's due to the RS232 standards design. It is basically not designed for long distance communication, as it is used in the past for communication between the PC and the keyboard, mouse, or even the communication between the PC and a modem. So for RS485 and 422, they are newer standards being published for long distance communication. So communications can be up to a range of 1,000 meters. And sometimes, due to the short range of RS232, a RS422 converter might be used to convert between 422 and 232 to be used as a cable extender for RS232, meaning that the signal is converted from 232 into 422 and later on reconverted back at a distance of maybe 1,000 meters back into 232. So it could be used, this standard could be used as a port extender for extending the cable length. Communication for the different standards. RS232 and 422 supports full duplex communication, meaning that when the controller is communicating or transmitting data to the receiver or the device can at the same time transmit response data or feedback information to the controller without the need to wait for the controller to finish transmitting. So it can transmit at the same time receive. So full duplex operation is possible. However, RS485, only half duplex operation is supported on RS485. When the controller is transmitting data to the recipient or the device would have to wait until the transmission stops before it can transmit new data to the controller or respond to the controller. The number of wires available or needed for RS232 is 3. So basically the pins are as follows: transmit, receive, and ground. Minimally 3 pins are required. But of course for RS232 standards, there are other pinouts configuration of 5 pinouts up to the limit of 8. So it can be anything from 3, 5, or 8 pins. But for the other pinouts, you may do a search online on RS232 standards for more information. But for control purposes, for most control applications, you usually only need to connect up the 3 pins, transmit, receive, and ground. That's all. For RS485 control, it's usually relying on 2 pins, A and B. And the third pin could be ground. But ground is actually optional, so not all devices require ground to connect. Alright. RS422 consisting of 4 wires, A plus B minus, B plus, B minus. It can be named slightly different, but basically it's 2 pairs of wires. Topology supported by RS232, 485 and 422 is also slightly different. 4232 and 422 supports a 1-to-1 configuration, meaning that you have one controller and you have one device. Alright. For RS485, it's a bus topology, meaning that a controller can be connected to one or more devices on a bus. And the bus is fully bidirectional, meaning that you can transmit and receive data on the bus. But however, as we have discussed previously, it is half duplex. So when the controller is transmitting data, all the devices in the bus network must listen to the transmission and only reply back when the controller finished transmission. Alright, devices used for the different standards are as follows. Projectors, AV receivers, and switches usually runs on RS232. Security cameras, PTZ security cameras usually runs on RS485. For RS422, to control PTZ camera or to do RS232 extension, in the case whereby, because of the short distance for RS232, for certain equipment that's being connected maybe 500 meters away from the controller, you will need to have a conversion to convert the RS422 data into 232 so that we can use it to control the devices that is running on 232. So this will actually overcome the cable distance limitation of RS232 by doing a conversion. Alright, so that's all for serial port. We will move on to the next. We have the infrared serial port next. This port emulates infrared communication signals from for an infrared remote control for any device. How it works is that the infrared codes are first captured into our software platform, and it will be fired from the controller via our infrared ports to the remote devices to be controlled. And the maximum distance of infrared cable extendable by a Cat5 or Cat6 cable is up to 50 meters. Number of devices controllable per port will be limited by cable distance. Basically, each and every port on our controller is capable of connecting 3 devices. But however, when you extended the length of the cable to, let's say, 10 meters, the number of devices controllable will reduce to 2. The main reason is transmission power. When you extend the length of the infrared cable, higher transmission power will be required to transmit the same data into the infrared adapter connected to the end of the cable. So the longer you run, the longer the cable run, the less the number of devices. So approximately, if you have a cable length that's less than 20 meters, 2 devices. If you have a cable length of greater than 20 meters, 1 devices. And how the devices is connected to the controller is actually via IR that can be purchased from Q. For multiple device control in one infrared port, the devices must be connected in parallel. This port may also be used as a serial port for RS-232 control. However, when you use this as for RS-232 control, feedback will not be available. Next is general I/O. General I/O, the term I/O implies input and output. When used as an input, we have 2 configurations, a pull-up on and a pull-up off. So if you are using it as a pull-up off configuration, there will be no voltage at the input and ground. This means that an external device can generate a voltage into the system between any range of 0 to 5 volt and pass into this ADC to be converted into a value between 0 to 1023. So this means that we can use the system to measure a voltage across these nodes, allowing for integration with third-party sensors or third-party equipment with analog voltage input. When you put the pull-up on, a 5 volt DC will be transmitted to the output of the I/O. This allows us to connect passive sensors which acts like variable resistors in the system. So when the sensors vary, when light sensor or temperature sensor is connected to the nodes, when temperature or light varies, the voltage across the variable resistor or sensor will also vary, allowing for detection of the temperature and ambient light condition by the use of the ADC. So the ADC in the general I/O allows us to integrate with low-cost passive components or sensors without the need to purchase expensive serial-based sensors for control or automation use. Digital output. When you are using it as output, it will be a digital output, and there are 2 configurations to the digital output. If you set the pull-up to be off, similarly pull-up on and off will actually affect the functionality of the digital output. When the pull-up is off, what will be created is a potential-free soft output with a maximum sink current of 80 milliamps. So when the pull-up is off, there will not be any potential here, and using the transistor, alright, here, we are able to switch the circuit on and off, meaning to short the output to the ground or not short the output to the ground, creating a contact closure or a relay. However, when the pull-up is on, a 5 volt or 4.3 volt will be sent to the output, alright, allowing us to set the voltage. So when the I/O, when this transistor switch is off, you will see a 4.3 volt. When the transistor switch is on, you will see a 0 volt. So this allows us to have a 4.3 and 0 volt digital output on the I/O itself. Next, we are running to the digital I/O. The digital I/O works slightly different from the general I/O in a sense that the general I/O has a free ADC inbuilt in the I/O itself. For digital I/O, you can only detect pure digital input and do a pure digital output, meaning that when you are using it as an input, a 5 volt will be sent to the output, and you can put a potential free switch over here, and we can detect opens or closed circuit by detecting the value of the voltage that's coming in. If it's less than 2 volt, it's a close. If it's more than 2 volts, it's open. And similarly, if you are using it as output, the on and off of the output here allows us to create a contact closure, contact closure or a switch in between the input and output, causing the the output to be switched to 5 volt or 0 volt if the output here is on. Next, we have the relay, analog and LAN ports. For relay, they are actually potential free switches that has got 3 pins, normally open, normally closed, and common. So inside the IPQ, normally when the default setting for the system will always be normally closed, which means that the common will always be connected to the normally closed when the device is, or rather when the controller is power off or is initially power on. Alright. So when you actually switch the relay on, or when you run a close command for the relay, the switch will actually cross over this way, connecting the common to the normally open pin and creating a closed circuit for the C and NO. Alright, so when the relay is energized, it will create a short circuit between C and NO. When the relay is off, you will create a connection between C and NC. So as the name implies, NO means normally open and NC means normally closed. And common, COM, or rather C is actually common, COM. Okay, for analog features a zero. For analog ports, it can be used to control analog dimming ballast or similarly controlled system using its 0 to 10 volt output. You can set the voltage on the analog port to any voltage value between 0 to 10 volts. The LAN port on the controller allows for both TCP/IP and UDP protocols and available for both client and server connection with any UDP and TCP/IP client or servers in the network. This allows Q to communicate with any third-party products supporting the TCP/IP and the UDP protocols. But however, for each product, the protocol will be different. So you will need to get protocol documentations for each of the third-party products to be able to support and control the third-party system. In lieu of knowing all the ports in the controller, let us go into designing of a control system. To design a control system, first thing we need to do is to get a list of devices to integrate into the control system. Next, when you have the list of devices, you need to find out the control methods or the method of control for each devices. meaning that can the device be controlled by infrared or can it be controlled by serial, and if serial, which type of serial port, RS-232, 422, or is it 485, or can it be controlled by TCP/IP or UDP? And if it's TCP/IP or UDP, do you need a client connection or do you need the host server connection for the device to connect in? And next, if the devices and controllers are not located in the same rack, you have to get the distance from the device to the control room where the controller is located. If possible, get the layout of the location to install the system, and on the layout, mark out the location of the devices and the control room. The reason for this is that there is a limit for the distance the signal can travel from the controller to the device. As what I've mentioned in previous slides, serial, there is limits for each different serial interface. For infrared, there is also a limit on how far the infrared signals can travel. After you have done that, you need to choose, the next step to do is to choose the correct controller from our catalog based on the number of ports of the various types of equipment needed for control. Also, consider the need for additional equipment or standard in case of long distance between devices and controllers. So all this, the choice of the correct controller and the number of equipment to be used in the control system project will be dependent on the devices, the method of control, and the distance from the device to the controllers. Finally, you may choose the interface or panel to be used to control the system based on requirements or budget. So a wireless touch panel may be spec'd in, or a wired panel, or even iPads, Android touch panels for that purpose. So you will be dependent on the user's requirement or the budget for the project. What we are seeing here is an example of devices checklist that you may use to help you in your design. So we have here the list of devices, and here the list of inputs or outputs or ports that is needed for the device. So for example, Blu-ray, usually for commercial Blu-ray players, only infrared is available for control. So you check here as yes and set the rest of the connection or ports as no. For example, AV receiver, you have RS-232 and you have IR and you have none of the other ports. So you have set RS-232 as in serial and you have set IR and you have set no to the rest of the ports. For video conferencing, we have got serial, we have got infrared, and we have got TCP/IP. If it's UDP, you may put in UDP/IP depending on the product. For projectors, RS-232, infrared, and the rest, and no other controls available. For PTZ, which is pan tilt zoom cameras, RS-485 is a norm. For screens, most screens allows controls via 3 relays or IOs, low powered. And if you are directly controlling the screen power, which is actually 230 volts to the screen, you may need a different configuration. Alright, so this is a sample or example of a devices checklist. You may use this device checklist on your next project to design a control system. Note, however, the distance for the devices are not found in this checklist. The distance for devices can be marked down in the layout of the location. Or you can take a picture, or you can draw the layout by hand. It will be good to have a layout of the project site, be it a layout from the client or a layout drawn by hand. So with this list and the layout of the equipment, or rather the layout of the location with the location of all the equipment, we can come up with a design. So the next thing to come out will be a single line diagram of all the equipment. So what should be contained inside the single diagram is all the equipment and as well as controllers or touch panels that is supposed to be in the system. Due to size constraint, we are unable to put a full diagram, but the short illustration of this diagram by the side shows you roughly how a simple diagram will look like. So we have a controller and you have got equipment connected to the port number on the controller itself. So projector connected to the serial 1 S1 port, and the TV connected to the IR1 port, Blu-ray connected to the IR2 port. To check out the ports available on the controller, you may look at our catalog. And to find out the names of the ports on the controller itself, please look at our controller's user manual. And with this, we have come to an end to the introduction on Q as well as a short introduction on control system design. Do let us know if you have any problem and feel free to contact us at support@qsystem.com.sg. That's support@qsystem.com.sg. Thank you for your time and enjoy learning Q. Goodbye.